Hi there, hard workers. Today we're going to be taking a look at Performance Tools LCD Circuit Tester. To give you an idea how your circuit tester works, it has LEDs in here that'll light up when both power and ground is present. You'll have to clip your probe onto either power or ground. The clip end here, we've got that attached to the ground side of our battery, and then with the probe end, instead of the clip side, you'll touch this to your other circuit, and if there is the opposite there, it'll light up. So currently we've got ground on the clip side, and our probe are touching on the positive of our battery post, and it lights up red. It also gives us a voltage reading on there, reckoned at about 12.5 volts. Now we could swap this and hook it up the other direction. So we're hooking our clip onto positive, and then we're going to take our probe and touch it to ground. And it also lights up, but you will notice now that it's lit up green, letting you know that your probe side is touching on ground and you have power present on your clip side. You'll also get a voltage reading there. And that's really nice that you get a voltage reading there because if you have any drop across your circuit, you can help detect that as well. So you can kind of check out the integrity of your circuit while doing this. It's kind of a special thing here. Most of your test lights will just have a light on it. It's really nice that we've got that voltmeter on there as well to get additional information. For example, currently now we're reading about 12.5 volts, but if I was checking this further on down the circuit, and if we had some corrosion in that circuit, I may only read 12.1 volts further on down that circuit, and I know, hey, the voltage has dropped from what it is here at the battery by a few tenths of a volt down there. Maybe I should look for a little bit of corrosion or a bad connection at that point. And it may even drop even lower. You may only have like 10 or 11 volts. And if you're checking it like that, then there's a good chance that you're finding, hey, this is probably why I'm finding where my issue is. My item wasn't working. I was checking my circuits along the way and I see a drop in voltage that's excessive. Check your circuits there. So we're going to go ahead and go through some examples of common uses of this and some little bit more in-depth tests that you can perform with a test light. Often people will use these to test the circuits at the back of their vehicle, and they usually do this when they plug up to your trailer and you find like, hey, I don't have tail lights, or I'm missing a turn signal or something like that. Well, rather than immediately digging in and trying to fix some wires, let's figure out, hey, where's the issue at? Is the issue on my vehicle side or is the issue with my trailer? That's where I like to start. So I've gone ahead and turned on the hazard lights in the vehicle as well as the tail lights. That should activate all of our signals. So we're going to take the clip here, we're going to hook this on ground, which is the exposed stud there. So we're just clipping that on there, kind of putting the rubber boot off to the side here a little bit to help keep me from touching it. And now we're just going to check our circuits. So here we've got 12 volts here at the back. So we know that our taillight circuit's working. And we've got a flashing signal there, giving us our 12 volts, so we know that that's working. And if we look here at the color of the wire coming in, that's yellow, so that's going to be our left turn signal. And then our right turn signal is the green wire, and when we check this one as well, we get our light lighting up and giving us our 12 volts. So we know that our vehicle side here is working properly. And this will also work when testing your 6- and 7-way connectors as well. You just need to pay attention to what the circuits are. So for the 4-pole ones, we were able to turn on tail lights and hazards to get all these operational. With a 7-way, you'll need a brake controller plugged in and somebody operating the output of it in order to be able to test that circuit. Your auxiliary circuit should normally just have power on it all the time, but sometimes you have to start the vehicle to get the auxiliary circuit to come on. So just pay attention to those so that way you know that you're getting the output back to your connector when you're checking. Just verify that your vehicle has that particular output. In this instance, if we had an issue with our trailer though, we know that our vehicle's okay, so we can go ahead and button up this side. We don't need to diagnose anything over here. We would then turn to our trailer and try to figure out, okay, why is that signal not working? So then we would do that from there. So here we've got a scenario for you where we're going to show you a short to ground and how to diagnose it. Currently I've got a scenario set up. So our board here, this is the load for our device. It's going off right now. And this is normally comes on when you put your vehicle in reverse. So let's say in our scenario, we put our vehicle in reverse, but instead of this coming on, nothing happened. Because this was what a short to ground would be like. If there was a bare spot on your wire, it would spark a little bit, and what would eventually happen, it would overload the circuit, and then it would pop your fuse. And if we take a look here, we can see that the fuse has blown. It's now open. So This was a temporary thing that we just put in there in place, but if you've got a short to ground in your trailer, it's likely always going to be grounded out like that. So let's just go ahead and set that scenario up. So now we're in the current faulted state. What we had started where the board was working was the proper fixed state. We simulated a short to ground. So we're just going to put this short to ground back. So I'm just stuffing that in there, and I'm just stuffing this in here just for simulation purposes. So now what's going to happen next is you go, oh, I got a blown fuse. Okay, well, my fuse is blown. I'll just put another fuse in. And when you go to put another fuse in, you go to pull it back in reverse or operate whatever accessory you're planning on operating, and it just pops the fuse again. Oh no, well now you know you got a real problem you got to solve. Your test light can be a real wonder in these scenarios because we can take that fuse out of there. Instead of wasting a bunch of fuses, what we can do is we can complete the circuit with our test light. And normally when you're doing this, you're probably going to have to take a paper clip or something like that to clip into the other end so you can poke it down in there. So I'm going to grab one of those real quick so we can mock that up. So now what we've done is we've taken our test light and we put it in place where the fuse used to be. The probe is in one prong, and then we used a paper clip and clipped it onto the clip side of the other side of the test light and put that in the other prong. And what you'll see there is that our test light has lit up. So what you'll want to check now is we know that this light's only going to light up if we've got a complete circuit that has a path all the way from power all the way to ground, and then it'll light that light. So at this point you can put it in the particular state in which you're trying to activate, whatever it be, a light or whatever. If you're putting in reverse to activate a light, go ahead and do that. We can see that it's lit up, and now you would just start disconnecting circuits until you figured out and isolated where the short was. One of the things I like to do first, if it's easy to get to, is to take away the ground at the very end of the circuit, because our test light doesn't take very much current to light up. So if it's like a bulb or something, it can actually go through the bulb. So let's make sure that if we take away the ground at the very end of the circuit, so this is the load at the end. This is normally like a brake light bulb or something. You got your power that goes to the bulb or whatever your load is, and then the other side just goes right to ground. Well, if we remove this ground here at the end, what should happen is your test light should turn out if there's no shorts. But if you look here, our test light's still lit up. That means that there's a path to ground still somewhere present. So you would work your way down the line to the next easiest connection point that you get to, and you would disconnect it there. If the test light turns off, then you know, okay, my short is between the point that I just disconnected there and then a point further towards the back of the vehicle, not closer to the battery. If you just keep disconnecting circuits and the light still lit up, then you know that you need to keep working your way towards the battery to find that issue. After I disconnect the one at the very back, what I usually do next is I'll disconnect the one here at the very front, and that way I've eliminated between those two connectors and I can start finding that point. So we know our short to ground's here because we did it here in this particular test scenario, but if we disconnect this circuit there, we have no more test light turned on because it's no longer shorted to ground. So that can be a really useful test item to find short to grounds without popping a bunch of fuses, because if you want to get power in the circuit to check for power, each time you'd have to put that fuse in there, and it'd probably end up blowing that fuse because of the current state it was in. But we can use our test light to get current through there and check it. Next, we're going to show you guys how to perform a voltage drop test, and this is one of my favorite tests for finding difficult issues that can arise with circuits, because you could have a circuit that's completed but still has high resistance or issues with it that can cause strange conditions to occur. So first thing we want to do is we're going to be using the voltmeter portion of our test light now to do these tests. So whenever you're doing a voltage drop test, the first thing you want to do is a baseline test. We want to see what the voltage is at the battery. So we've got 12.4 volts right at our battery. We've got this lead on negative, that on positive, 12.4. We're going to use our test circuit once again, and I want to show you guys something neat. This circuit's complete. All that it needs is ground to hook on, and then I'll turn on our board. This board does have a delay in it before it begins to activate the beeping, so we are going to get a little bit of time before it's going to go off on us there. But I wanted to show you guys that while we had 12 volts here at the battery, if we check here at the ground connection where it's not connected to ground, it's currently disconnected. Look at this, guys. We got about 3.1 volts there. So we still have some voltage that is present there. And in most cases, you're going to read very close to battery voltage here unless the resistance gets too high. If we go ahead and clip this on ground, whenever you're checking like a light bulb or any kind of circuit, when you're checking your voltage drop, that can tell you the conditions of your circuit. So we're going to complete the circuit by clipping this on. That'll complete our circuit here. So now if we check, this is on the ground side here, nothing. It doesn't even light up at all, because all of our voltage should drop across our load. It should drop completely across here. If you still have voltage present on the other side, that typically indicates that you have a poor connection in here somewhere. I'm going to go ahead and disconnect it to turn that off. But that usually indicates you got a poor connection somewhere in here, because there was still some voltage present on the other side of your load. That means that there's corrosion or a bad connection. Maybe you got like the two wires are barely touching here. That poor connection there, that high resistance, is actually consuming some of that voltage in order for it to get across that to get to ground. And that can cause your lights to light up very dimly. If it's a computer module, sometimes it can cause it to wig out to where it does very unexpected things. So by doing your voltage drop test, that's one of my favorite ones to be able to narrow down those issues. And we're going to just run down this circuit here. So we know at the battery, when we clip on here, we had about 12.4. And it's normal over the length of wire to see about 1/10 of a volt drop. So we've got it right here at the battery, 12.3. We're going to go right just to the other side of our circuit protection. And we're right at about 12.4, 12.3. We haven't dropped any voltage yet. And we head up here to our tester. Looks like we can't quite get in there. 12.4, still good there. And then we go right onto the other side here while it's activating. And we get absolutely nothing. It's completely dropped across the circuit. You always want to see that. If you see something like, maybe you see like 10.4, more than likely this thing's probably just dropping a little bit of voltage. You've actually really got a major issue on here on the ground side. The more voltage you have on the ground side of the circuit past the load, the more issue you know you've got right here. The other thing we were checking is when we were checking voltage drop there, we saw that it was nearly 12.4 all the way up to our load. Let's say right here at the load, at the light bulb or whatever your load is, you're only measuring maybe like 6 volts. And of course your light's probably not going to work. Whatever here is probably not working properly. You know, between this point here and the battery up here, you had 6 volts that has dropped across that circuit. So you need to check the wiring between this point and that point to figure out why that voltage dropped. And again, it's typically going to be caused by a poor connection or heavy corrosion in that circuit. And that completes our look at Performance Tools LCD Circuit Tester.